Hello friends, welcome. Today in this video, we will be discussing the meaning of correlation. Now let us start with the definition. Correlation is a coefficient in the form of a single number that tells us to what extent variation in one go with the variation in the other. In the simplest term, the correlation coefficient details about the change in one variable leads to the change in the another variable. It has nothing to do with the causal factors. It can only explain the strength of relationship between two variables and their direction. Direction means whether the relationship between these two variables is either positive or the negative. So, the central idea of correlation is the relationship between the two things or the two data sets or the two variables and the degree of relationship and the direction of relationship. That is the only purpose or the objective of the correlation. In the introductory part, the association or the relationship between two variables or two phenomena that is measured using the correlation formulas developed specifically for this purpose. Now, when we talk about the correlation, remember, we are discussing the simple linear correlation. Simple correlation means it's a kind of linear relationship between the two variables. Linear relationship means when we plot the relationship between these two data sets, that resultant line should be a straight line. It explains how one thing or one variable varies with the another one. It's a single number indicator that paints a picture of relationship between the not only two variables, two situations. We can express this relationship or the association only when the phenomena is measured in the metric data. It explains a kind of interdependency. If you take the literary meaning of correlation, it's a kind of dependence of both the variable on each other. So that is the interdependency. The change in one variable leads to the change in the another variable. That is the interdependency. Correlation attempts to draw a line of best fit that passes through the two variables. And the value of the Pearson correlation, which is the one of the types of the correlation we will discuss in the subsequent slides, indicates how far away all these data points are to this line of best fit. And this is also known as the bivariate correlation. See, bivariate correlation, the Pearson R correlation is also known as the bivariate correlation. Suppose you take a group of students and ask them to stand in a football ground. Now, the line of best fit is the straight line, but touches the maximum students, or the line should pass through the students that have a maximum density, which are nearer to that line. You can make a number of lines, but the line of best fit will be that line which passes through that group of students which have highest density. So that line will be described as the line of best fit. And dear friends, the coefficient of correlation, when we calculate, they only try to paint that line of best fit through the data set of the two variables. Now, in statistics, the most common type of correlation, we use two types. Pearson Product-Moment Method, and the Spearman rank difference method. The Pearson Product-Moment Method, that is represented by the small r. It's a very simple method and the most robust correlation technique. The Pearson correlation coefficient is the covariance of the two variables divided by the product of their standard deviations. So this is the definition of Pearson Product-Moment Method. So what is covariance? Covariance means co plus variance. When we use the word prefix co, that means joint. Covariance is the joint variance expressed by the variables between which we are going to calculate the correlation coefficient. The product-moment method is the covariance of the two variables divided by the product of their standard deviation. Which type of data we will use for this product-moment method? We will use for the data that meets the assumptions of normal distribution. In other words, it's a parametric test. Now, how to compute the coefficient of correlation, that is the Pearson R product-moment method. It's our various formulas, 5 to 6 times formulas upon the raw data, upon the covariance, upon the standard deviation, different. But the most common formula and the simplest one I have described here. You know for what purpose we use? To determine the strength of association between these two variables and their degree of association. Okay, for that we use this formula. It is in front of you. Rx, y means the coefficient of correlation or the correlation between the x and y, that is represented by the R subscript xy, which is equal to n. N is the sample size. So this is the capital Greek letter represented by the sigma, that is the summation, means x into y, the product of x into y minus summation of x multiplied by the summation of y. So what is x, capital X and capital Y? This is your row scores, simple row scores. Okay, so that is the divided by the same n here. Here n means the sample size of the x, and summation x square means if you square the row score of the x and add that square and then you multiply it with the sample size of that particular variable, then it has to divide it by you sum the total values of the x, then you square it. Okay, so these values this value must be subtracted from this one, and same for the y, and you take under root and divide this value by the value when you get from the under root. So that will be your R. In the next video, we'll be discussing how to calculate the product-moment method. Don't worry about that. In this video, you just understand the computation procedure of the calculation of product-moment method. Now, the second most common used correlation method is the Spearman rank difference method. That is represented by the rho, a Greek letter, looks similar to the italicized English letter P. This nomenclature, Spearman, stands for the statistician, the psychologist who developed this method. Rank means when the data set is in the ordinal scale, in the order. When we use the ranks, first, second, third, fourth, this way when we have data in the ranks form, then we use the Spearman rank difference method that is the correlation between the two variables. Now, when the data is in the rank form or the ordinal form, it certainly not going to meet the assumptions of normal distribution. And when data doesn't meet the assumptions of normal distribution, then we call that particular data set is non-parametric. Hence, Spearman rank difference method of correlation is the non-parametric test, and it doesn't have the condition of linearity, whereas product moment method have a condition of linearity. Means the Pearson product moment method measures the linear relationship between the two variables, whereas Spearman rank difference method doesn't bother about the linearity of relationship between the two variables. It's a very important difference between the two correlation methods. And particularly in mathematical science, in the pure science, the product moment method is preferred. So the Spearman rank difference method is calculated using this formula, rho. This means Spearman rank correlation coefficient is equal to 1 minus 6 summation d I square. D means deviation. When we match the ranks, so how much these ranks deviate among them. So you calculate that and square that and then finally sum up them. So here n is the number of observations. So using this formula we can calculate the Spearman rank difference coefficient represented by the rho. Now the salient features of correlation. Correlation is one of the important tools of scientific prediction. Science is only do one thing, prediction of the phenomena as accurate as possible. So correlation is a statistical technique that helps the science in predicting a phenomenon. The causal relationship means correlation explains the causal relationship. It doesn't answer the why that relationship exists, but it explains that there is a relationship between these two variables or two data sets. Interestingly, its value varies from -1 to 1. While calculating the correlation coefficient, if you come up with a value that is greater than 1 or lesser than -1, certainly you have made some calculating errors. So you must remember that the value of the correlation coefficient varies from -1 to 1. The next important feature is the correlation is the directional index. It's a very interesting feature of this correlation. It explains the direction of the relationship between two variables. So what is direction? Whether it is a negative one or the positive one. See, this is a continuum of the relationship. If your value lies here, then there is no relationship between the two variables. If your values start from this side to this side and reaches here, this means the relationship is perfect, but it is a negative one, and opposite is true this way. Means this side the relationship is perfect but positive one. So what is the meaning of positive correlation? Positive correlation means the change in one variable will leads to the change in the other variable in the same direction. For example, if x increases, y also increases. And in sense of perfect positive correlation, if x increases by 1 unit, y will also increase by 1 unit. That is the perfect positive correlation, and opposite is true for the perfect negative correlation. And the last important feature is the it can be linear as well as the curvilinear. Linear correlation will be explained by the PSNR method, and curvilinear can be explained by the rank difference method. But product moment method doesn't explain the linearity of relationship between the two variables x and y. So this is the continuum of the correlation coefficient. Now, some traditions. The statisticians follow some traditions while calculating the coefficient of correlation. These are not the scientific processes or the techniques that has to be followed, but they are the traditions. So why these traditions are followed means they helps in gaining maximum from the minimum resources. Means when we follow these traditions, these provide us the optimal output. So these traditions are developed through the experience. To compute a correlation, whether it is a Pearson method or the Spearman method, there must be at least 25 observations. If the data set or the n or the sample size is less than 25, it is not appropriate to use the correlation coefficient. And to understand the degree and the direction of the correlation coefficient, there is a broad classification is made by the stalwarts of the statistics. It is not the absolute one. Remember this point. These are the traditions that has to be followed. So, if your correlation coefficient is from 0.002 plus minus 0.2, that is considered as an indifferent or negligible correlation. If there is no value of association between these two variables. If it is plus minus 0.2 to plus minus 0.4, it is considered as a low correlation. And from 0.4 to plus minus 0.7, it is a substantial or marked or the moderate correlation. And if your value is plus minus 0.7 to plus minus 1, it is considered as a high or very high correlation. But if it reaches to plus minus 1, that is known as the perfect correlation. So now, if you want to express the correlation as an agreement of ranks, we will express this way. In the first case, this is the data set of A variable, this is the data set of B variable. So if the line is straight between these two ranks or these two data set, then R will be 1. That is a perfect correlation. In the case 2, if the lowest number of this data set associates with this data set, this is the perfect R minus 1 correlation. I am talking about the product moment method here. And if the relationship or the association between the two data sets is in this fashion, then it cannot be predicted. It has to be calculated using the formula. That is the product moment method. Now, what is the context for decision making in regard to coefficient of correlation? When we decide the results upon the calculated coefficient of correlation which we have received, which we have calculated from the data set using the formulas, so that coefficient correlation has to be interpreted in the context of these 5 situations. That is, the nature of selected variables must be considered while taking decision based upon the coefficient of correlation. Then the significance of the coefficient, whether the coefficient of correlation we have calculated is significant or not, and then only we are going to make decision based upon the coefficient. And the third most important context is the variability of the group and the reliability coefficient of the test used. The test which was used for the collection of the data, whether it is a psychological test or any other test. So how much that test is reliable one? So what is the coefficient of reliability? If the coefficient of reliability is higher, then only we are going to make the decision based upon the coefficient of correlation. And finally, what is the purpose for which the product-moment method, the R, is computed? So before making decision based upon the coefficient of correlation, so these 5 criteria are to be considered by the researcher to make the interpretation and the informed decision as objective as possible. Now, dear friends, these are my references. You must read these references to understand the meaning of the correlation and its objective and purpose. If you like the contents and the presentation style of this video, share with others. But if you have any suggestion, any question or any critical comment to make, just drop a comment in my comment box, or you can email me at vamasudit@yahoo.com. Thank you friends for watching.